Now there's a state coulomb's law as applied to what electrostatic and state its mathematical word expression. So you can write coulomb's law. It states that it states that the force of interaction between two stationary point charges is directly proportional to the magnitude of the interacting charges and inversely proportional to the square of the distance between them. So that's it. State that the force of interaction between two what stationary point charges, that is your Q1 and what Q2, okay, is directly proportional to the what the product of the magnitude is directly proportional to the product of magnitude of the interacting what charges and inversely proportional to the square of the distance between them. Now this is the definition you are going to give to them. Okay, now the old one you normally use, then they will tell you that the force of attraction or repulsion. Why they normally use the word attraction or repulsion? Because the charges, both of them can be what positive. Are you getting me? Or positive negative, or negative. If they are like charges, what happen? They repel what each other, and the type of force that occur there is known as force of repulsion. If they are unlike charges, what happen? They attract what each other. That's why they use the word. The force of attraction or repulsion between two point charges is directly proportional to the product of the charges and inversely proportional to the square or the distance between them, or distance what apart. Is still the same thing. Now, so this is it. From here, F, you have Q. This is how it goes. Now, from here, this is your Q, maybe positive and negative. Sometimes it can be positive, it can be negative. Are you following? So from here, there's a distance from here to here, and there is a distance from here to what? To here. So now from here is what? Is arrow. From here is what? Is arrow. Now the distance from here to here, now arrow times arrow give you what? Arrow square. Are you following? So hello. So your force of interaction is directly proportional. So this is directly proportional sign. Are you following? Okay, directly proportional to the what? The product of the magnitude of the interacting charge. That's Q1 and what? Q2. Are you following? And inversely proportional. The word inverse is 1 over. The word inverse is what? 1 over. That is 1 over the square of the distance between them. The square, which is arrow what? Arrow square. For every proportional sign, there is a proportionality word constant. Are you following? So that's why we have it as F equals to K, Q1, Q2 over arrow square. So this is your Coulomb's law of what? Electrostatics. So this is the mathematical expression they ask you to write out. Okay. Now your K then is known as Coulomb constant. K is what? Coulomb constant, which is 9 times 10 raised to power what? 9 Newton meter square per what? Newton meter square per what? Coulomb square. So this is a constant value for what? For K. Now we also have formula for K. K is also equal to 1 over 4 pi SLN naught. 1 over what? 4 pi SLN naught. This is permittivity of free space. This permittivity of free space also has its constant word value. Okay, our E naught is equal to 8.854 times 10 raised to power minus 12. The colon square per Newton meter square. So this is the value for what? E naught. Now, from sometimes either you write your Coulomb's law in form of this. For in place of k, you can still represent it with 1 over 4 pi what? E naught. At the end, you have it as F equals to what's k? 1 over 4 pi SLN naught, right? Then times Q1, Q2 over R square. Where our F will be equals to 1 times Q1, Q2 is Q1, Q2. Then over 4 pi SLN naught R square. Now, this very formula and this very formula, they are quite different but slightly related. Now for this is when you are giving your what? Your k. Are you following? That is when you make use of this formula. Then if you are giving your permittivity of free space, which is your E naught, that is when you make use of this word other formula. Are you following? Okay, so according to this question now, you were asked to state Coulomb's law, and this is it, and also state the mathematical word expression, which is this. So it's just for you to write F. Mathematically, F is equal to what? K Q1 Q2 over R square. Can I write where F? Yes, you write it that way. Where F represents what? The force of attraction or repulsion, or force of the interacting charges. Force of what? Interacting charge. Then Q represents what? The charge. Then R represents what? The distance. The K represents what? Coulomb constant. All right. So this is what they ask you to do then. You have to state it and state the mathematical word expression. Sometimes they will only ask you to just state just the mathematical expression. Are you getting me? And explain the meaning of the word parameters. The meaning of the parameter, that is what each of the parameters stands for. Are you following? Sometimes they will ask to write just this formula and state what each of the parameters stand for. Are you following? Your F there represent the force, Q represent charge, R represent radius, and K represent a Coulomb constant. So that is for that. All right. Is from a positive charge of magnitude 10 raised to power minus 90 coulomb. So we are giving the distances. Now we are going to calculate it at 1 millimeter. You also calculate it at 1 what? Centimeter. You also calculate it at 10 what? Centimeter. You also calculate it at what? 100 centimeter. Now please pay attention. From here, what are we looking for? We are looking for what? E. Is it not? Now this time we are giving our charge Q to be 10 raised to power minus what? 9 coulomb. Okay, we are giving our arrow 1 to be what? 1 millimeter. So what do you do? Convert to what? To meter. How do you convert from centimeter to meter? Divide by 1000. So this is 18 as 1 over 1000, which give us 0.001 meter. So our arrow 2, which is the second distance, is what? 1 centimeter. Convert to what? Meter. That 1 over what? 100. That is 0.01 meter. Arrow 3, which is the third distance, was going to be 10 centimeter. I convert to what? Meter. That's 10 over what? 100. That is 0.1 meter. Then while arrow 4, which is 100 what? Centimeter, which is 100 over what? 100, will give us a 1 meter. All right. And in the exam, you'll be giving your Coulomb constant. Are you getting me? Even though you are not giving, you should know it that your K is equals to 9 times 10 raised to power 9 Newton meter square per Coulomb square. In some cases, they might give you like pi in the question. You don't need your pi. Are you following? Yes, if you go through other years, So they normally add what? Pi to it. You don't need it. All right. So this time around, now to get our E1 at R1 equals to 0.001 meter. So we are giving E1 to be KQ over R square. Are you following? So from there, our E1 will be equal to what's K? 9 times 10 raised to power 9 times what's Q? 10 raised to power minus 9 over what's R1 there? 0.001 square. So from there, E1 will be equals to multiply these two. Multiply. 9 times 10 raised to power 9 times 10 raised to power minus 9. So what do we have? 9. Then over 0.001 square. We have 1 times 10 raised to power minus 6. So to get our E1, divide these two. 9 divided by 1 exponential minus 6. So we have 9 million, right? Which is 9 times 10 raised to power 6 Newton per watt coulomb. So electric field is measured in what? Newton per watt coulomb. You did electricity last semester. So the next one is to at R2 equals to what? 0.01 meter, right? 0.01 meter. So we have E, that is E2 equals to KQ over R2 square. So from there, what's our K? 9 times 10 raised to power 9 times Q was given to be 10 raised to power minus 9 over what's R2? 0.01 square. So from there, if you multiply this, we have what? 9. 0.01 square, it gives us 1 times 10 raised to power minus 4. So if we divide these two, our E2 will be equals to 9 divided by 1 exponential minus 4. It gives us what? 90,000. 900,000. That is 9 times 10 raised to power 4. So Newton per watt per coulomb. So the next one now, at what? R3 equals to what? 0.1 meter. At R3 equals to 0.1 meter. So from there, our E3 becomes KQ over R3 square. So what's our K? 9 times 10 raised to power 9 times 10 raised to power minus 9 all over what's R3? 0.1 then square. So our E3 will be equal to, if you multiply this, we have what? 9. Then 0.1 square give us what? That is 0.01. So our E3 will be equals to 9 divided by 0.01 give us what? That is 900 Newton per watt. 900 Newton per watt coulomb. Are you getting it? Yes. So the next one we are at what? At R4 equals to what? 1 meter. That is our E4 equals to KQ over R4 square. So from there, what's our K? 9 times 10 raised to power 9 times 10 raised to power minus 9, which is the charges. They're divided by what's R4? 1. That is 1 square. So from there, E4 will be equal to, if you multiply this, we have what? 9. And 1 square is sitting as what? 1. And 9 divided by 1, what do you have? 9 Newton per watt coulomb. So that's your final answer. Any question? All right. Okay, it's just like this question. They said, determine the electric field strength at a distance of 100 centimeter from a positive point. The same thing. Okay, compute the electric field strength at the distance. We are giving a distance, just one distance this time around, right? And this distance is arrow to be what? 100 centimeter. It's written as 100 over 100. We give us what? 1 meter. Okay, from a positive charge of magnitude. What magnitude? Charge to be what? 10 raised to power 9 coulomb. So in this question, you can see now, since it's exam, I picked it up from the exam questions. You can see that they gave them what k, right? So from there, what's k? 9 times 10 raised to power 9 Newton meter square per coulomb square. Can see this time they gave them what? Pi to be what? 3.142. Now you can still make use of pi if you want to make use of pi. You still arrive at the same what? Answer. But that one will require you to make use of permittivity of what? Free space. Are you following? But now no need of that. So you just go ahead with the question. So we are looking for E, where our E is equals to KQ over what? R square. So from there, our E will be equals to what's K? 9 times 10 raised to power 9. Are you following? All right. 9 times 10 raised to power 9. Then times what's Q? 9 10 raised to power 9. All over what's R? 1. That one was square. So from there, E will be equal to, multiply this. What do we have? 9 times 10 raised to power what? 18 divided by 1 square is written as 1, right? So if you divide this, what do you have? We say 9 times 10 raised to power 18 Newton per coulomb. So that's the answer. Is it not easy? It is. So you can copy that. Just that the one we did before, we were giving their various distances, right? That's why it take a little while to solve that. All right, so you can copy that. Alpha. Alpha is twice electron. Alpha is what? Alpha is what? Twice electron. And in the question, we're given our arrow, which is our distance, to be what? 10 to power minus 11 centimeter. What do you do? You convert to what? To meter by divided by what? 100. So this is taken as 10 to power minus 11 divided by 100. So what do we have? We have 1 times 10 raised to power minus 13 meter. Is it not? Yes. All right. So this time around, we are giving our k to be 9 times 10 raised to power what? 9. So Newton meter square per coulomb square. So we are giving our electron to be what? 1.6 times 10 raised to power minus 90 coulomb. So this time around, to get our alpha there, alpha is a charge. Are you following? So what do? You substitute this into this expression to get your alpha. Since our k, our alpha is equals to twice electron. Are you following? Then become alpha equals to 2 times what's our electron? 1.6 times 10 raised to power minus 19. So 2 times this, what do you have? 3 point what? 3.2 times 10 raised to power minus 19 what? Coulomb. So you are taking this in form of charge. Don't forget, for our force, F is equals to K. Normally, it ought to be Q1, Q2 over R square, right? Then in place of Q1 and Q2, represent it with alpha 1 and what? Alpha 2. So it become alpha 1 and what? Alpha 2. And alpha times alpha give you what? Alpha square. So from there, our F will be equals to K alpha square over R square. Are you following? So from there, our F will be equals to what's K? 9 times 10 raised to power what? 9. Times what's alpha? 3.2 times 10 to power minus what? 19. All what? Square. Then all over what's radius? 1 times 10 raised to power minus 13. 1 times 10 raised to power minus 13 what? Square. So from there, force will be equals to 9 times 10 raised to power 9 times square this. What do we have? 1.024 times 10 to power minus what? Then all over this times what do you have? This raised to power 2. 1 times 10 raised to power minus 26. Isn't it? Please confirm. So our force will be equal to multiply the numerator. Multiply the numerator. 9 times 10 raised to power 9 times 1.024 times 10 raised to power minus 37. So what do we have? 9.216 times 10 raised to power minus 28. Then all over 1 times 10 raised to power minus 26. So our f will be equals to, so divide this, 9.216 exponential minus 28 divided by 1 exponential minus 26. So we have what? 0.09216 Newton. So that's our final answer. Please, any question?